So we were discussing non-uniform circular motion in the last class, yeah? And we did a couple of questions for non-uniform circular motion. First, I'd like to do some more questions, and then we'll go on to the non-inertial frame of reference. But it is very, very important that you understand the application of non-uniform circular motion. Okay? For those of you who are still confused, please remember that all you have to do is draw the tangential axis, the radial axis, and the third axis. Of course, you won't be able to draw all three. And once you have drawn whichever axis is possible, then you make the FBD, you find out the components of forces, and along the radial axis, you write down force towards the center minus force away from the center is equal to mv square by r. And along the tangential axis, you write down force is equal to m into A tangential, and A tangential is either you can write dV by dt or you can write alpha r. Force along the third axis always remains 0. So these three equations, once you have obtained these three equations, should be able to solve for whatever value is being asked for. Okay. Chalo. So let me start with the question. So we have this rod and we have sort of a bead here. This will rotate like this. Chalo, so please try this question. Gravity free का मतलब there is no gravity, there is no mg. Good, very good, doctor. Yes.
क्या हो भाई बाकी लोग?
This is the circle along which it will rotate. This will be the radial axis. This will be the tangential axis. And although we don't need it, this will be the third axis. Now, what are the forces acting on this? Let's label the axis. Third axis, tangential axis. What are the forces that are acting on this? ग्रेविटी फ्री एनर्जी तो है नहीं, तो ये बीड के सराउंडिंग में क्या है? बीड के सराउंडिंग में रॉड है, रॉड का सरफेस है, तो बीड के ऊपर जो फोर्सेस पॉसिबली लग सकती हैं वो है एन और म्यू एन, एन और फ्रिक्शन, सॉरी म्यू एन नहीं बोलना चाहिए क्योंकि म्यू एन इज द मैक्सिमम वैल्यू ऑफ फ्रिक्शन. So the only two forces that can act on the bead are normal reaction and friction force. Now friction must be parallel to the interacting surfaces. Therefore friction must be like this. Friction must be along the radial direction. यहाँ पे फ्रिक्शन होना चाहिए. And since there is a tangential acceleration, we know that there is a tangential acceleration. The normal reaction must be along the tangential direction. So now all that remains is to write down the equations. So friction is equal to m omega square r, whatever the r may be. Right? In this case, this distance is r. This distance is r. And along the tangential direction, we get n is equal to m alpha r. So since we are talking about slipping, this implies that friction must be maximum. And therefore we get mu n is equal to m omega square r, which is nothing but alpha t square r, right? Remember that since initial omega is equal to 0 and alpha is equal to alpha, final omega will be equal to alpha t. And n is equal to m alpha r. Simply equate both we just put in the value of n. So mu m alpha r is equal to m alpha square t square r, m alpha r, right? As it should happen because r तो given नहीं था, तो आंसर में r आ नहीं सकता है. So I get alpha t square on the right hand side and mu on the left hand side. So t must be equal to root mu divided by, right? Now, the biggest problem that I have found with students not being able to, वही बता रहा हूँ biggest problem that I have found with students not being able to do this type of questions is that there is some predetermined sort of some predetermined sort of picture in your minds. ये तो टेंजेंशियल फोर्स हो ही नहीं सकती है, ये तो रेडियल फोर्स हो ही नहीं सकती. आई डोंट नो व्हाट यू आर लुकिंग आउट फॉर. My suggestion is that please do not have any predetermined notions about what the forces are going to be. Right? The process is very logical, and I told you that you are not supposed to think, you are supposed to do a very simple observation. What is what is it that we observe here? Well, we observe that there is a bead which is placed on a rod, right? And bead on a rod ka matlab hua that there must be an interaction between two surfaces. The moment I say that the thing is gravity free, this means that the only object in the surrounding of the bead is the surface of the rod. And therefore, the only forces that are capable of being applied on the bead are normal reaction and friction. Normal reaction must be perpendicular to the interacting surfaces. Therefore, normal reaction must be perpendicular to the rod, right? And friction is always parallel to the interacting surfaces. This means that the friction should be parallel to the surface of the rod. In this context, therefore, friction must provide the radial force and normal reaction must provide the tangential force. अगर मैं पहले से सोच के रखूंगा कुछ और नहीं है तो पॉसिबल ही नहीं है. So then the question itself becomes impossible, right? So what you have to remember is a tangential radial force या centripetal force क्या हो सकती है, ये मैं बार बार बोलते आया हूँ, फिर से बोल रहा हूँ. रेडियल फोर्स क्या हो सकती है? कुछ भी हो सकती है. एम जी एन फ्रिक्शन, टेंशन, स्प्रिंग फोर्स या एक्सटर्नल एजेंट की फोर्स. टेंजेंशियल फोर्स क्या हो सकती है? कुछ भी हो सकती है. एम जी फ्रिक्शन, एन स्ट्रिंग टेंशन, स्प्रिंग फोर्स या एक्सटर्नल एजेंट. या दो दो फोर्सेस हो सकती है, या दो के कॉम्बिनेशन हो सकते हैं, या एक का कंपोनेंट हो सकता है, या दो के कंपोनेंट हो सकते हैं, या फिर तीन के कंपोनेंट हो सकते हैं. सो नो टाइप ऑफ. अब यार जो है, अब सर्कल तो ढूंढना ही पड़ेगा ना. अब उसमें देख, मैंने ब्लैक कलर की एक ऊपर एरो बनाई हुई है गोल, तो वो गोल एरो आपको बता रहा है कि कैसा रोटेशन होने वाला है. बीड ऑन द रॉड है, इट इज रोटेटिंग. सर्कल तो आपको ढूंढना ही पड़ेगा ना. आई मीन उसका तो खैर कोई, देयर इज नो फिजिक्स बिहाइंड दैट ना. सर्कल तो you have to identify. Maybe my diagram was a bit off, but I don't think in any question there will be any ambiguity about कि सर्कल कहाँ है. हाँ भाई, सब कुछ गिवन रहता है. हाँ. चलो एक और, one more. Please notice, okay, all of you, please notice, जो लोग जगे हुए हैं, please notice that the actual physics and maths behind this question was very easy. The only thing that you have to do is arrive at these two equations. That is what I said at the beginning. Identify the radial axis, identify the tangential axis, identify the third axis, draw the FBD, and then write down these equations. Once you've written down these equations correctly, then it's just a matter of simple mathematics. Okay? Chalo, next question. I hope all of you are able to do this. Okay, so we have a circular track, and on this circular track, we have a object like so. And I'll try to draw the diagram as best as I can. So there are two surfaces here. So a box of mass m is placed on a circular track of radius r. The coefficient of friction between vertical walls of track and box is mu. Okay? The floor is frictionless. If box is given a velocity v naught as shown, find its velocity after one circle. Mass of box. Right? I hope this is clear. एक circular tub type की object है which has a horizontal surface, the floor of the tub, and it has a vertical surface, which are the walls. And I take a block and I project the block with a velocity of v naught. Coefficient of friction is given. अब आप बताओ. ये कैसे पॉसिबल है पार्थ? आई मीन अभी तो मैंने बताया ना, फ्रिक्शन हमेशा पैरेलल होता है, नॉर्मल रिएक्शन परपेंडिकुलर होता है, राइट? How can they have the same direction? हाँ फ्रिक्शन ऑपोजिट रहेगा ना, तभी धीरे होएगा ना समय के साथ वो। कांस्टेंट वेलोसिटी कैसे होएगी राधिका? फ्रिक्शन एक्ट कर रहा है ना। नहीं, वेदांत, वेलोसिटी बढ़ नहीं सकती है ना। आई मीन आई होप यू विल appreciate the fact that if there is friction and you kick something on the floor, then ultimately it stops, right? It does not speed up. Zoheb लिखा हुआ है, the box is given a velocity of v naught as shown. देखो, मैंने ये सेटअप लिया, आई होप ये सेटअप सबको समझ में आ रहा है। जब मैंने ये ब्लॉक को क्लिक किया तो ये ब्लॉक ऐसे गोल गोल घूमेगा, और because of the fact that there is friction between the wall and the vertical wall and the block, right, this friction will slow down the block. We want to find the velocity of the block after it has taken one round. That means that its angular displacement is 2 pi. तो इसका velocity, speed क्या होएगा, right? So radial axis, tangential axis, third axis. I hope ये सबने बना लिया, ये सबसे इम्पोर्टेंट है। बाकी सारी चीजें तो अपन बाद में सीख भी लेंगे और अपन कैचअप कर लेंगे। ये सबसे इम्पोर्टेंट टेक अवे है इस चैप्टर। थर्ड एक्सिस पे नीचे एमजी एक्ट कर रहा है, कोई तो फ्लोर का नॉर्मल रिएक्शन ऊपर ऐड कर रहा है, जिससे मुझे कोई मतलब नहीं है। फिर वर्टिकल वॉल है तो एक नॉर्मल रिएक्शन इधर होना चाहिए एन, और वेलोसिटी के ऑपोजिट होना चाहिए फ्रिक्शन, और वो होना चाहिए म्यू एन, क्योंकि ये तो केस वन है, वन सरफेस इज फिक्स्ड, एंड सिनारियो टू है, राइट? सॉरी, सिनारियो, हाँ सिनारियो टू भी बोल सकते हैं, थ्री बोल सकते हैं, that the block is moving. So if the block is moving, then the friction must be opposite to velocity. In this case, friction is like this. So along the radial axis, then I write down N is equal to mv square by r, or I can write down m omega square r. Right? And this is what I want you to realize. You look at the previous question, along the tangential axis you have the normal reaction, and along the radial axis you have friction. But here things have turned. Along the radial axis you have normal reaction, and along the tangential axis you have friction. Mu n must be equal to m into dv by dt, right? And along the third axis, which really has no consequence or any role here, simply write down n dash is equal to mg. अब अगर मैं बोल देता कि नहीं फ्लोर में भी फ्रिक्शन है, right? अगर मैं बोल देता फ्लोर में भी फ्रिक्शन है, तो रेडियल ये टेंजेंशियल एक्सिस में एक और आ जाता म्यू डैश एन डैश, where mu dash would be the coefficient of friction between the floor and the, हाँ, अगर ये दो इक्वेशन लिख दिए, इसके बाद आप नहीं कर पा रहे हो, दैट्स ओके, बिकॉज दिस इज द मेन थिंग दैट यू हैव टू लर्न इन दिस चैप्टर. दिस इज द मेन थिंग. ये जो दो इक्वेशन लिखी हैं, प्लीज लुक एट दीज इक्वेशन. दे आर नॉट रियली डिफिकल्ट, राइट? दे आर इजी. द ट्रिक इज टू गेट your mind to get rid of any presuppositions, identify the circle on which the block is going to move, draw the radial, tangential, and the third axis, draw the forces acting on the object, find components if required, and then write down these equations. Please notice that my words, they always remain the same, right? Hey, Zoheb, मतलब मेरी चॉइस है ना यार, मैं तो कुछ भी लिख सकता हूँ ना, राइट? I can call you by your first name, I can call you by your second name, I can call you by your full name. That is a choice that I have. I can write m dv by dt, or I can write m into alpha r. कौन सा यूज करना है जब हम सॉल्व करेंगे, that will ultimately decide which expression you are going to use. अब यहाँ पे हमसे पूछा जा रहा है फाइंड द वेलोसिटी आफ्टर वन सर्कल, राइट? सो ऑब्वियसली आई एम नॉट गोइंग टू यूज दिस, आई एम गोइंग टू यूज दिस. सो एम बी स्क्वायर बाय आर into mu is equal to m dv by dt. Right now, there is a catch here. I wonder if anybody has caught. I wonder if anybody has caught it. There is a small catch here, which we should recognize from the study of motion that we have done. So I know that this friction is opposite to velocity. Therefore, there are two ways to interpret this. Since friction is opposite to velocity, or since we know that as time goes on, velocity will decrease, okay, there should be a minus sign. In fact, there should be a minus sign here, but I'm not going to draw it here. I'm going to make this here. Right? So negative sign indicates that velocity decreases with time, or that friction is opposite to velocity. M or M cancel out हो गया, right? And I get a very simple equation, that is mu v square by r is equal to minus dv by dt. But I don't want dv by dt. No. Because dv by dt में time आ रहा है, and I don't want, I'm not interested in time, right? So what should I write? I should write here v dv by dx. Remember that dv by dt and v dv by dx are the same things. So now I can cancel out one v, and I can rewrite this equation as minus dv by v, okay, v के टर्म्स मैंने एक तरफ लिख दिया, is equal to mu by r into dx. Right? And now what should I do? I should integrate this, integrate this. From where to where should we integrate? Well, the initial velocity is v naught, and at that time the distance traveled is 0, and we want the velocity when the distance traveled is, after one goal chakkar, 2 pi r. Okay? So I integrate, I'll get ये माइनस साइन में उधर ले जाता हूँ तो मेरे पास आएगा ln v by v naught is equal to minus mu by r into 2 pi r. R और r भी कैंसिल हो गया. So v is equal to v naught e raised to the power minus 2 pi mu. This will be the velocity. Right now, I agree this is very weird. This is, but if you think about it, the physics of the circular motion, is only this. बाकी जो भी चीज मैंने लिखी है ये काइनेमैटिक्स से आ रही है, and this is variable acceleration problems which we did. Okay. ये आ रहा है भाई, सबको समझ में है, ऐसा नहीं. लास्ट स्टेप ln है राधिका, वहां पे ln a is equal to b, so a is equal to e raised to the power b. याद है ना, ये किया ln किया है ना, log पढ़ा है ना. ln x is equal to y, then x is equal to e raised to the power y. So v by v naught is equal to e raised to power minus 2 pi mu. V therefore will be equal to v naught e raised to power minus 2 pi mu. Okay, chalo, one more. Okay, now the two questions that I have given are perhaps the toughest. I'm sorry about that. So let's do some easy questions now. Okay. ये एसएस क्या होता है भाई? ये क्वेश्चन, हाँ हाँ स्क्रीनशॉट लेना है. हाँ, मैं डर गया, एसएस लेना था, मेरे को लगा कुछ तो मैंने छोड़ दिया, मिस कर दिया, डरा दिया मेरे को. So this question was asked, I think, by Radhika. So if particle moves along a circle with velocity, with speed rather, velocity magnitude, v is equal to a root s. A is a constant, s is the distance traveled. Okay. The radius of circle is r. I don't know. I think it was r. R था ना? क्या था राधिका? Find the radial and tangential acceleration as a function of s. सही पूछा है ना राधिका? मैंने यही था ना? हाँ बिल्कुल सही स्मिथ. यस. Find the angle between velocity and net acceleration. नहीं नहीं, टेंजेंशियल गलत बता रहा है इसमें। एक मिनट फिर से देखूं क्या लिखा है। क्या लिखा है उसमें, ठीक से उसको मेक इट मोर मैथमेटिकली। हाँ, रेडियल तो इजी है ना, रेडियल तो। ओ वेरी गुड, यस वेदांत, यस। अब देखो आपका आंसर में, देयर इज, यू कैन जस्ट एक स्टेप और सोचो आगे अभिजीत। आपने आंसर में मेरे को दिया, जो भी आपने लिखा है आप उसको देखो, और उसमें व्हाट यू कैन डू इज यू कैन फर्दर सिंप्लीफाई। हाउ कैन यू फर्दर सिंप्लीफाई? एंड व्हेन यू फर्दर सिंप्लीफाई इट एक्चुअली बिकम्स वेरी वेरी इजी। For those of you who have done this, नहीं एस तो, अरे एस के टर्म्स में निकालना है ना। नहीं नहीं, लिख रहा हूँ। Hmm. तो यहाँ पे we have a circle and we have the radial axis and we have the tangential axis. हाँ, yes. So the particle is moving with a velocity given by a root s, and s is basically the distance traveled by the particle. So a radial is v square by r, and radius given as r, v is a root s, so this will be a square s by r. A tangential is equal to d by dt of v, which is d by dt of a root s, which is equal to a तो कांस्टेंट है बाहर आ गया, d by dt of root s. I wonder how many of you remember this. This is why we had discussed differentiation in such great detail. d by dt of root s, right? You cannot do this. You have to use chain rule, and you have to multiply and divide by ds. So when you do this, when you calculate, you will get a into 1 by 2 root s into ds by dt. Right? Now notice what is happening. ds by dt is nothing but v, right? So since ds by dt is equal to v, we get a into 1 by 2 root s into v, but a into 1 by 2 root s into v is equal to v तो a root s, v तो दिया हुआ है हमको a root s, तो ये रूट एस और रूट एस कैंसिल हो जाएगा और मेरे को मिलेगा a स्क्वायर बाई 2. This is a tangential. Okay, this is a tangential. Now a tangential is coming out to be constant, and that should not really come as a surprise because v is proportional to root s. Remember ये आपने कहाँ देखा है, v square is equal to u square plus 2as. So this is a case of constant acceleration. So the tangential acceleration should come out to be constant. It is not a very big surprise that we should get. So now this tells me that look, in this direction the acceleration is a square by 2, and in this direction the acceleration is equal to a square s by r. Right? And therefore the net acceleration must be here, a net. And we are supposed to find the angle between velocity and net acceleration. So the angle between velocity and net acceleration is this theta, right? It is this theta. This is very simple to calculate, right? Tan theta, tan of theta will be equal to this axis, this thing, which is a radial, right? So tan theta is equal to a radial upon a tangential, which is equal to a square s by r upon a square by 2, which is equal to 2s by r. This is the angle between velocity and net acceleration. चलो ये वाला प्लीज डू दिस वन. अभी सो रहा था क्या? हाँ, it is a similar question. So yes, हाँ सोएब सही है. क्या हुआ रजत, तेरा जवाब नहीं आ रहा है, शांत हो गया है. हाँ. So basically what we are saying is that it would be mass into radial axis. Tension will be this. So T will be equal to mv square by r. अच्छा, Kt is equal to mv square by r. So V is equal to r kt by m. आज तक मैंने कभी टेंशन को डिफरेंशिएट किया है? आज तक मैंने कभी टेंशन को डिफरेंशिएट किया है? फिर एक मेरा कजन तो बहुत साल पहले वो आईआईटी का एग्जाम देने जा रहा था. आता जाता कुछ नहीं था बेचारे को, और उस टाइम आईआईटी जेई का एग्जाम वो होता था रिटर्न वाला. तो वो गया आईआईटी का एग्जाम देने के लिए और पेपर मिला, तो पेपर में कुछ समझ में तो आ नहीं रहा था. जो भी उसको क्वेश्चन दिखा उसमें वो खूब सारा डी बाई डी टी और डी बाई डी एक्स लिख के आ गया. यही होता, ये जादुई छड़ी है, इसको कहीं भी छुआ दो तो सारे क्वेश्चन हो जाते हैं. बट ऐसा नहीं होता. You have to do things with meaning. हाँ, वेलोसिटी आ गई मेरे पास, तो अब मेरे पास टेंजेंशियल एक्सेलरेशन आ जाएगा. अब डिफरेंशिएट करेंगे. So A tangential is equal to dv by dt. This will be equal to root rk by mt 1 by 2. रूट आर के बाई एम तो कांस्टेंट है, बाहर आ जाएगा. रूट टी का डिफरेंशिएशन 1 by 2 रूट टी. And therefore A net will be equal to under root of A tangential square kt by m square. A radial, sorry, हाँ, sorry, जो है बिल्कुल सही बोल रहा है. Yes, A radial square plus A tangential square, which is rk by 4m. Right, this will be the net acceleration. ठीक है, right? चलो, so I will stop here. अरे tangential dv by dt से मिला ना. A tangential is equal to dv by dt. अबे रेडियल ये है, रेडियल इधर होता है, इज इक्वल टू एम वी स्क्वायर बाय आर. और ये जो होता है ये dv by dt होता है. ठीक है. हाँ अभिजीत, अभी अभी मैं बताता हूँ, 10 मिनट रुक जाओ, बता रहा हूँ. चलो, I'll see you guys in the next class. Next class में we'll do centrifugal forces and that's it. That will end the chapter. Okay. Again, you need practice for this, so please with HCV and the हाँ स्लाइड में अभी 10 मिनट्स के अंदर में भेज. So you need to do HCV and the booklet, please. Okay. Chalo, I will see you in the next class. Chalo guys, bye bye.